Now next we will look at factor theorem. Okay, see, factor theorem is actually a special case of remainder theorem. So in remainder theorem what we have understood is you have a polynomial p of x, okay, which is having a degree greater than or equal to 1, and you have a linear divisor x minus a. The remainder will be p of a. You find p of a, you get remainder. Okay, now when you find the remainder, if you get remainder is equal to 0, in that case, what does that mean? You can divide p of x completely by x minus a. So you can divide p of x by x minus a, that's why you are getting 0 remainder. Now in this situation, you can call x minus a as a factor of p of x, and that's what factor theorem is. So factor theorem is actually a special case of remainder theorem. When the remainder is 0, everything else is same, the condition, everything is same. You have a polynomial p of x which is having a degree n greater than or equal to 1, then you have a linear divisor which is x minus a, and when you find p of a, what is that? That is nothing but the remainder. When you find p of a, if you are getting 0, what does that mean? X minus a is a factor. Or if you want to tell it in a reverse way, you have a p of x polynomial which is having a degree greater than or equal to 1, and when you divide with x minus a, you are getting remainder 0, means x minus a is a factor. Or the opposite way is, you have a polynomial p of x with degree greater than or equal to 1, and you have a divisor x minus a. If this x minus a is a factor of p of x, you will get remainder 0. So two ways. What are the two ways? First line remain the same in both cases. P of x is a polynomial where the degree is greater than or equal to 1. Now let's take two cases. If the divisor, which is a linear polynomial, which is x minus a here, if it's a factor of p of x, you will get remainder 0. Or the divisor is x minus a. When you find p of a, if you get remainder 0, then x minus a is a factor. That's what factor theorem. And I hope you understood it completely. So factor theorem is a special case of remainder theorem. Now the only difference is, when it comes to remainder theorem, r can be anything. You can get different value for remainder. It can be 0 also. But when it comes to factor theorem, r is 0. So if remainder is 0, we are talking about factor theorem. The given divisor is a factor. If remainder is any other number, then the given divisor is not a factor. So in remainder theorem, the remainder can be any number. In factor theorem, the remainder have to be 0. So how about the graph? See, if you generalize the graphical representation or graphical understanding of remainder theorem, it will be like this, right? You have dividend. Okay, let's take this as p of x, and by looking into this you understood that the degree is 2, quadratic, parabola. Then you need to have a linear divisor, so it will be a straight line. Let's draw something like this and see where the line cut the x-axis. That's the 0 of the divisor. So 0 of the divisor you got. What you need to do is, I told you to drop the perpendicular and measure the distance. Where that perpendicular touches the dividend, measure the distance. What will be this distance? That is a remainder. So this is the divisor, x minus a. So this distance is actually the remainder. What is that actually? P of a. That is what p of a. This is in which case? Remainder theorem. So this distance you will get as the remainder, or this distance is what p of a. It is not 0. Now if this distance is 0, then that becomes your factor theorem. Then the divisor is a factor, so you don't have a remainder. So this distance will be 0. That means p of a will be 0. Let's draw one for that also. Let's take again a polynomial with degree 2, so quadratic polynomial. Let's draw the line also. It will go like this. See where the line cut x-axis? Here, right? This is the point where the line cut x-axis. Now if you observe here, there is no gap here, right? No gap here. So from this you can, this is what x minus a, and this is what P of x. So if you find P of A, there is no distance, you are actually getting 0. That's what factor theorem. I hope you understood both remainder theorem and factor theorem in both ways, algebraically as well as graphically. So remainder theorem will look like this graphically. This is what P of x. You can have a divisor. See where the divisor touches the x-axis. Draw a perpendicular and see where it touches the dividend. So this is what your x minus a divisor, and this distance is what your remainder or P of a, and this is what your remainder theorem graphically. And then what about your factor theorem graphically? Then let's try to understand that also again. Let's take a graph like this. Now let's again degree 2. Let's draw the divisor. Divisor cut at the x-axis at this point. So this divisor is x minus a. Same divisor in both cases. This is a polynomial P of x. Okay. See, this is a point 0 of the divisor. So when you find P of a, you understand that this is 0. So actually this is a remainder. So remainder is 0 in this case. So that is what factor theorem. In factor theorem, remainder will be 0. So x minus a is a factor. So in other words, if you need to tell in words, how will you tell? You have a polynomial P of x. The degree is greater than or equal to 1. Degree n greater than or equal to 1. When you divide with a linear divisor, let's take x minus a. Now this much is common. Now let's understand what is remainder theorem and what is factor theorem, right? Factor theorem and remainder theorem. So you have a polynomial P of x, degree n greater than or equal to 1. You are dividing with a linear divisor x minus a. What will be your remainder? Remainder will be P of a. In factor theorem, what will be remainder? Remainder is equal to P of a is equal to 0. So here you get remainder, here you get remainder as 0. When the remainder is 0, I call this x minus a as factor of P of x. So I hope you understood factor theorem and remainder theorem completely.